First part is what? Yes, experimental setup. That means apparatus. Because the experiment is alpha scattering experiment, the first thing you need to have is what? Source of alpha particles. So there is a source of alpha particles. If there is a source of alpha particles will move in all directions. But you want them to move in particular direction only, specific direction. So you can have a material, yes. Which one? Lead. Why? Lead enclosure. Because it is a good absorber of alpha particles. Doesn't allow alpha radiation to pass through the same. So these alpha particles pass through what? Yes. Yes, collimator. Means what? Something which can use voltage to give direction to alpha particles. This is collimator, black color. These alpha particles then move on. This is what? Source of alpha particles. And these radiations will hit what? Yes, these radiations will hit, yes, thin gold foil. Gold foil. And what is the observation? You need to observe that after hitting this, alpha particles are available in a different directions. Some alpha particles are available here, some are available at this point, some are available here. Alpha particles are available in a different direction. So you make use of what? A detector. And you can detect, say, at any angle, say theta. You can place a detector and detect number of alpha particles at any point. So what is the experiment? You have a source of what? Alpha particles. Lead enclosure is there to give it, to absorb alpha particle in a different direction. So you get alpha particles in a desired direction only. A collimator will do what? Give it a direction. So it will hit a gold foil. After hitting the gold foil, alpha particles get scattered in a different directions. And aim of the experiment is to find out what percentage is available at theta is equal to 0, 10, 20, 90, 100, 120 up to say 180 degree. 2 minutes with you to draw the diagram. And B part is what was the observation? Observation in form of a graph. Yes. Observation in form of graph. What is along y-axis? Yes. Theta is along x-axis. Check it. Angle is along x-axis. 0, 10, 20, 30. Say 0, 30, 60, 90, 120, 150, 180. What is along y-axis? Yes. Numbers. Number of particles available at any angle. This is 0, 30, 60, 90, 120, 150, 180. So number of particles, millions of particles are fired. And how the observation? When the detector is at this point, theta is equal to 0. How many particles when theta is equal to 30 degree? How many particles when theta is equal to 60? How many particles when theta is equal to 90, 120, and how many particles when theta is equal to 180 degree? The observation was, number 1, the graph was of this type. That means for certain values, 10 degree, 40 degree, 50 degree, and this is these dots represent what? Data as per the experiment, and this is the extended one. That means only these few observations were there, and the graph is plotted taking only those few, say 4 or 5 observations. So point number 1 is that dotted curve is theoretical prediction and bold dots are practical observation. 2, 0.14%, very small, 0.14%, undergo what? Theta is equal to, yes, theta is equal to approximately 1 degree. Then 1 in 8,000, yes, theta more than 90 degree. And 1 in million, 1 in million, theta is equal to 180 degree. Here n theta represents what? Number of alpha particles scattered through an angle theta and this theta. The observation is, if you have 1 million particles, majority will pass as it is. Only very small percentage undergoes very small deflection 1 degree. Particles undergoing 90 is 1 out of 8,000 and 1 particle. This is the angle 0, this angle is 180. So 1 out of a million comes back also. This was the observation. Time with you is 2 minutes to write the observation. Conclusion is, you can say, I will put it this way, observation is, majority passes undeviated. 1 in a million retraces, that means turns back at what angle? 180 degree. So first there is experiment, then there is observation, and then there is a conclusion. What is the conclusion? Number 1. Yes. After the experiment, what he concluded was, number 1, yes, size of nucleus is of what order? 10 raised to power minus 15, 10 raised to power minus 14. 2, yes, yes, all positive charge is at a center, that is nuclei. 3, radius of the nucleus, that is the same as the first one. Radius of nucleus is, yes, 10 raised to power minus 4 times the radius of atom. Volume is proportional to, yes, volume of a sphere, 4 by 3 pi r cube. So volume of the nucleus is equal to, yes, 10 raised to power minus 12 times the volume of atom. Why? Because volume is equal to 4 by 3 pi r cube. If r is 10 raised to power minus 3, 10 raised to power minus 4, 10 raised to power minus 4 power 3 comes out to what? 10 raised to power minus 12. That is why radius is 10 raised to power minus 4, 1 by 10,000. And volume is 10 raised to power minus 12. 2 minutes with you to write.